Here are some problems from section 1.4, and this problem right here says evaluate the function and simplify. G of t equals 3t squared minus 12. Well, what I did is I noticed that this is a quadratic. I went to the quadratic sheet. I put in my coefficients of 3, 0, because there's no t to the first power, and then minus 12. And then it says, what is g of 5? Well, g of 5 just means put 5 in for x. So right here I'm just going to put 5 in for x, and I get 63. So that's the answer to that one. Find when g of t equals 0. That does not mean put 0 in for x or put 0 in for t. It means the g of t, the y value, that's the y value. See, g of t is over here for y. When is the y value equal to 0? So to get that, all I really have to do is just put 0 in for y, and I get two answers, 2 and negative 2. Now, on this problem it says, on part C, it says, what part of the graph is part B finding? Well, part B, you're letting y equal 0, and when you let y equal 0, you're getting the x-intercepts. And if you look up here, you can see that the x-intercepts are 2 and negative 2. So that's what that one's finding. On part D, it says, find the average rate of change from 1 to 4 seconds. Well, just put in 1 for an x and 4 in for an x. Here's the y values that you get by evaluating that function. Like if we run 1 through this function, g of 1, we would get negative 9. And if you put 4 through that function, 3 times 4 squared minus 12, you get 36. Then to find the average rate of change, I have this area here ready to go, so I would just do equals, parentheses. Now subtract your y values, this y minus this y, close parentheses, divided by, open parentheses, this x minus this x, and there you go, 15. Now that's what the average rate of change is from 1 to 4 seconds. The next one says get the average rate of change from 1 to 3 seconds. Well, once you have that formula in there, when you change this, it will update this number automatically. So let me make this a 3 now, 1 to 3 seconds. And now the average rate of change is 12. From 1 to 2 seconds, the average rate of change is 9. And the way what we're doing here is getting closer and closer to the actual average rate of change at 1 second. Like if you want to get really close to the average rate of change at 1 second, then put in some number very, very close to 1. Like let's try 1.1. And you see that you get 6.3. And if I would go even closer to that, let's try 1.000001. What do I get? 6. So the actual slope of the tangent line, or the rate of change at t equals 1, the slope of the tangent line at 1 would be 6. I didn't ask that. Again, if any of these, you just plug in the different values, like 1 to 2 seconds. But you can see it was getting closer to that that value of 6. Look, 1 to 4 was 15. 1 to 3 is 12, 3 less. 1 to 2 is 9, 3 less. So 1 to 1, or exactly at 1, is going to be 3 less, or 6. So let's do the next one. Put in your coefficients, negative 2, 3, and 1. And then what is f of 3? Well, I'll tell you what. So I don't ruin my... well, I'll show how to type it again. But I could do this, just say, let's put in a whole bunch of values down here. Start, like do a whole table. And here's the value at 3. Here's the table. Starting at 0, incrementing to 1, it's negative 8. That's what the function is. I didn't want to type it here because I already have a formula in right there. Find when is f of t equals 7. So this f of t means the y value. When is the y value 7? So just put a 7 in here. And never. It's never 7. In other words, if we look at this graph, the graph of this thing is never going to be 7 units high. And you can see it's a parabola opening downward. The vertex point is a maximum, and it doesn't go above 2.12. So that's why you get these imaginary solutions right there, complex solutions, non-real. And part C says find when f of t is equal to 0. That would be the x-intercepts, and they're right there, or you could put 0 in for y right here. and get the x-intercepts. And then now this average rate of change stuff, well, okay, D, what is part C finding? That's finding the x-intercepts. Part E, find the average rate of change from 1 to 3 seconds. So we'll do that right here, 1 to 3. And it's automatically calculated here since I put the formula in. Okay. And then 1 to, let's see what else we got. 1 to 3 seconds, 1 to 2 seconds, 1 to 2 seconds. It dropped 2. So 1 to 1 second, it's going to be dropped 2 more, -1. And so that's the slope of the tangent line would be -1. But the next one actually says 1 to 1.5 seconds. So let me do a 1.5 right here. 1.5, and there it's -2 right there. And that's how these problems work right there. You can see it's the same type of thing here for this quadratic, average rate of change. This quadratic right here, evaluated at x equals 10, the y-intercept. To get a y-intercept, you put 0 in for x. How many candles to break even? To break even, the profit would be 0. So you're finding the x-intercepts. To make the sales 3, put 3 in for y, and the average rate of change from 2 to 4, well, that's where after you put in the coefficients, you put in the one x to be 2, the other x to be 4. Again, probably the hardest thing on this is getting this formula typed in here. Again, here's how you do it. You do equals the y's subtracted divided by the x's subtracted. And I'll stop it right there.